Yes. Hello there, my name is Pavel and I'm working for 2G's company. As I was introduced, our company is a city information reference and navigation service, a very good thing that actually makes your life in the city easier. I am responsible for web development. My team is called Infrastructure and Operations, or IO for short. We are supporting infrastructure for web development. We are providing our services to teams as a service. And we are dealing with all problems inside our infrastructure. Stack that we are using is very versatile. We have Kubernetes, we are writing on Python, on other languages. We are using Elasticsearch, Cassandra, and of course Postgres, since we love this database very much, as it is one of the core elements of our infrastructure. Today I'm going to tell you how at one moment we required a fault-tolerant cluster for Postgres, and we needed to integrate it with all other elements of infrastructure. We had to enable monitoring, configuration, logging, backup. So it was a very challenging task that was required for our production infrastructure. So it's not about things inside Postgres, it's not about how Postgres is operating, it's all about how we build infrastructure around Postgres. Well, it may seem that it's very easy, just take it and build it, but in reality it's much more complicated. And let's start with the objective itself. So our production team are writing application. A number of application is constantly growing. Before we were using PHP, Python and Java, Scala. But then we started to use Qlang and other modern languages, including Node.js. As a storage, we are using Postgres to store our data. We encountered a lot of questions like what if we use MySQL or other databases, but Postgres won. As we are practicing DevOps practices, our teams are involved into operations, so some services are supported by themselves. And the same stuff applies to Postgres, so each team could install Postgres, could configure it, and so on and so forth. As time goes, the number of Postgres instances grew with different versions and different configurations. It was very challenging. It was. Then we started to migrate to Kubernetes, and even more databases appeared, since we required some storage for migration, for intermediate applications, and so on and so forth. So it was a complete mess. Teams tried to use Ansible or Chef for installation and Postgres configuration, but the most interesting is that the easiest way is to make everything on your own manually, or just to call IO team to ask for help. So the load on our team was very heavy, because they were spending their time to find the problem, then to come over, then it took us some time to fix their problems. And there were some guys who could install Postgres of version 8 while it was already 9.4, and we understood that we needed to do something with this, because it's okay when they are doing something on their own, but it was a complete mess, and we have decided to make a common solution. And we said, what are you actually needing? What do you need to make everything good and easy? And we started to implement to implement this solution. First, since it's all about production, we need to have a cluster. We need to have several replicas. We need to have master in a cluster. We need to have failover automated if cluster crashes, just to make everything running. Also, optionally, we had a requirement to move replicas to another data center for fault tolerance and for disaster recovery, so applications could run on other data centers, at least in read-only mode. Of course, we needed to have balancing. We need to have pooling and backups. Backups was one of the main requirements. Of course, for point-in-time recovery, we also needed log files recovery. Of course, we had to do something with monitoring and logging and integration. And since we are following the paradigm infrastructure as a code, we decided that the application would be running in deploy mode. We were using Ansible and Python to do so, and Bash too. We're using Bash very intensively too. So the main point was to make it like a comprehensive solution, so any team could take our deploy, change some variables, secrets or keys, or events, and then deploy a fault-tolerant cluster. So we wanted to have it like you are hitting deploy button and everything is ready. And since we are using corporate GitLab, we wanted to have everything in continuous integration and continuous delivery in practice. So like you are hitting deploy button and then in a few moments you have a working cluster. Now let's have a closer look at everything that I have described to you. For cluster, we have picked up Postgres of version 9.4. It was around 3.5 years ago when version 9.4 appeared, and 9.6 was just released, as far as I remember. But we upgraded our solution to version 9.6 in order to have replication. We decided to use the streaming replication, which is the most reliable and the most popular. No problems with that. For clustering, we have chosen replication manager from second quadrant, and over these 2 days people were arguing about replication manager, that it doesn't support some features, but over our period of using this replication manager, we have not encountered a single incident when there is something bad with the failover or there were no errors. So replication managers switch the cluster always in case. Of course, there was some downtime, just around 2 minutes, because it takes some time to think about failover. Also, we have written custom failover command. This is a common. This command actually allows to switch clusters. We are using scripts. We are using balances. It checks balances. It checks that balances are available, and then the failover is executed. So after this, the master switches to slave, and then we get a new master, and replicas go to a new master. We have a few data centers in Novosibirsk. Also, we have some premises in Moscow. So we needed to have 2 replicas in Moscow. first we added them to repmgr cluster, but once we started our operations, we found out that the connection is poor. We had some problems with ping, with lags, and eventually we gave up this idea because our cluster always had some warnings, and monitoring started to say that something changed in cluster, maybe we need to check something. Replication was very poor, so eventually we made a schema like this. Out of rep managers we took out Moscow nodes, we made the standard hot standby, and through restore they get archives of wall logs. In fact, we are still suffering from lag problem because replicas are lagging behind in Moscow from Novosibirsk data centers, so they are restoring themselves. Replication is still running, and application that are using these replicas, they are aware of this, they understand that it may happen, and as a fallback they always have Novosibirsk nodes in the cluster. As far as problems are concerned, there are no significant or major problems apart from slow operations of fcomment, since we're using a standard rsync, so logs from master go to archive through rsync SSH, so if master starts operating, it is slowing down, but we know how to deal with it. Most probably we will switch archive into streaming mode, so it's not a big problem in fact. Alright, as far as balancing is concerned, we have decided that we need to have fault-tolerant balances. In order to do so, we have dedicated nodes. They have keep alive. They have virtual addresses of keep alive. So if one keep alive crashes, the second gets its address. So it's like they're having two addresses, and these addresses are balanced in DNS. When application connects to a cluster through round robin, they get a virtual address of the first balancer or the second virtual address of the second keep alive. Also we have pgbouncer, which is a very decent pooler. No problems with that, it is operating in normal mode, but there is one small problem that it can have only one backend, and it has to have connection to a master. But we decided to add pgpool. We liked it because it knows where master is located in cluster. It knows how to balance queries on slaves. It was very good. We started to operate it, to run it, but at a certain moment we had to do like this, because with the pgpool we always had some problems with no reasons. It could just throw away master out of balancing. Also the built-in analyzer that is analyzing queries, sometimes it couldn't decide whether it's a query for write or for read. It could send a read query to a replica, and then application started to crash. So we decided to throw pgpool away. pgbouncer is now looking only at master. Deploy provides a backend to pgbouncer, and the failover command switches to backend and then smoothly resets everything. So pgbouncer has a constant connection with master. Well, everything looks okay, if not the following problems: that master is very heavily loaded, and due to very good conditions our applications started to support read-only points, so now they can connect to read balancer and to write balancer to make write operations. So we make the same pair, we introduced read balancers like we did it before, and also we have installed HA proxy that actually knows where slaves are located and can query them through round robin. Equally, our applications started to support pooling on their side. They started to use things like he can pool, and it enables us to save connections for balancers, and after this things were made even easier. As far as backup is concerned, we decided not to make things too much complicated. We are using Barman for base backup. We are using backups every 2 days in late night where the load is the lowest one. Also, we are using wall archiving for point-in-time recovery. In order to check backups, we need to be sure that we always have backup that we can restore. So we have a host, and every night after backup is executed, it can restore the previous backup or the current backup, and it rolls some wall files just to check that point-in-time recovery is working. So check is executed, the base is restored, then it launches another script, it goes to a database, it checks all tags, and then it signals that to our monitoring tool that everything is okay and backup is being deployed. So as far as drawbacks are concerned, they're very typical. Archive command is very slow, and actually it requires a lot of space since we are not compressing wall files, since we are saving CPU resources and time, just to be very fast in case of failure. Monitoring. We are using for monitoring Prometheus. It is using a metric collection pool model. It goes to services and calls for metrics. So for each component of our system, and actually we're talking about all components that do not know how to give away their metrics, we needed to have some exporter that would collect metrics and give them to Prometheus, or we could write it on our own. We are writing them on Golang, Python, Bash. We are using standard exporters like Node. For our core system, we are using Postgres exporter, which allows to collect all Postgres metrics. We are using exporter for pgbouncer, written on our own. It was written on Python. And also we have written custom C groups exporters on Belang just to know how much resources the system is using to maintain every single database. We are collecting all system metrics, including CPU, RAM, and I/O, network consumption. We are collecting metrics across all components. In Postgres exporter, the situation is that you are writing on your own queries that you would like to be executed in a database. They are executed and then you collect them. So metrics are limited only in your mind. We also collect a number of transactions, a number of modified tuples, wall files position, just to check if anything is lagging. Also, it is a must to know what is happening with balances, the status of sessions, and so on and so forth, and everything we collect there. We are checking metrics in Grafana, and this is how the graph of exporters looks like. So we always have a chance to see how much CPU resources the database consumes.
So they asked me to delete things, so sorry about that. So as in any monitoring system, we have alerts. In Prometheus, Alert Manager is responsible for alerts. We have written a lot of alerts for clusters. We always know that the failover has initiated or is over, or it has been completed successfully or not successfully. So we monitor all these things through alerts. They signal us through email or to the corporate Slack, or we receive phone calls saying, wake up, you have an issue. We have successful backups and recoveries. We check whether the base is available for recording, whether the balances are available. So we monitor the full route from balancing query to the base. We also monitor test recovery to understand that we have backup available, that it's operable, that it's being deployed. The next item is logs. With logs, we wouldn't have too many of them. In our company, we collect logs. We used Elasticsearch, Kibana, and Logstash for that. Postgres and all components of our solution collect logs in CSV format, and they are collected from the disk by Python Beaver. It collects it and gives it to collect stash. It is enriched there, refers to corresponding commands and add appropriate information, and in Kibana you can easily view the logs, aggregate them and sort them out, etc. So the teams asked us to install pgBouncer. This is a thing that helps you easily analyze the logs. This is the main purpose of this thing. It is written in Perl. We didn't like it very much, however, because we need to deploy an additional host for it. But it is now operating in Kubernetes and receives logs from Logstash, and Logstash gives the TP logs. And in pgBouncer, you can find slow queries and understand how it can be fixed. Deploy. As far as deploy is concerned, we had to make it very simple. To make the tool understandable, we used Ansible to write deploy. Have you ever worked with Ansible? Oh, very well. We wanted to make it repeatable, depotent, to be able to use it not only at initial employment but in operation. We wanted to automate all operations that could occur outside of Postgres, changing configuration in QL Postgres. We wanted to have all the versions available and quests, and to track what has been happening through the depository history, to understand who has made changes and what type of changes. So we have written deploy in Ansible. We had to use 25 roles for that, but all components are installed through those roles. So you don't need to install anything else. You launch deploy, and then you have a workable cluster. We only need to do the inter request in the monitoring system. You need to indicate where it should go to collect the matrices. So 20 rows we wrote ourselves. 12 out of them are outdated. We wrote them only for this deploy, and I don't think they'll be used anywhere else. So they are in deploy in a dedicated catalog. So we had to localize all the roles, the ones we retrieved from the internet. We had to localize them because Roskomnadzor has become very active and bans hosts and GitHubs. So we decided to place the roles in our depositories. We also used embedded Ansible capabilities like environments. We have testing, production, and staging. Under staging, we understand almost production, but without user traffic. if we use embedded Ansible capabilities, if you need 2 or 3 testings, or if you need to test a feature, you can add it into the additional environments. You add variables, press deploy, and then you get the operable cluster. Secrets, keys, passwords, we store that in keys and encrypt through Ansible. So these are embedded capabilities in Ansible, and they're well known. Because we install Ubuntu Linux, so we do it from depositories, and anything that is not provided through packages, we package it and store it in our local act. So we need it to avoid issues when Roskomnadzor decides to ban something, and to expedite deploy as much as possible, because locally things happen much quicker. We try to automate all routine operations. Any change of the configuration, adding of databases, users, read-only users, anything like extensions, for example, into the database, changing the balancing modes, because some use transactional balancing, the other part uses prepared statements, so they use session balancing for that. Sunboot's cluster works in an automated mode. At the first launch, you select a certain variable, and then the cluster is ready to work. But then later you need to turn off the variable, because you launch the deploy with that variable. You'll have a clean cluster again. You need to remember that it is reflected in the documentation. Deploys is in the Git repository in our internal GitLab. Everything happens in the branches. It's a standard workflow, and if everything happens in the branches, we do not deploy anything from branches. We create MR by our internal practices. The MR, for MR, we ask people from our team who understand this matter. So when the merge is approved, it is sent to the master and then deployed to the cluster. We also wrote Bootstrap for bare metal in OpenStack. This is very handy, especially if you need a lot of testing. We can use native OpenStack API through Ansible modules, or in OpenStack we have Hit API, and you can launch them in templates. If you need to test something in the branch, you connect this Bootstrap, which you can deploy it. So you deploy the cluster, work with this cluster, and then you say, no, I don't need it, delete it. So the virtual machines are deleted in OpenStack. So everything is really good. For Iron machines, we wrote a Bootstrap. It's an embedded capability in Ubuntu. It asks several questions by the menu. So it asks you several questions about the disk, about the network, and then you get the node to be able to use in the deploy. So you write it into the inventory and you can launch deploy. Everything will be all right. Also, deploy includes tests. Tests are written in Ansible. The tests are infrastructure tests. So we launch them only in the test environment. So first they launch cluster, then they break the cluster, and then they check if everything is available from the balances, that the backup is available, that the database is recovering. So we test all this. And the final item is a about embedded capabilities of GitLab. It can launch jobs. Jobs are separate steps performed. For instance, by steps we mean syntax check, deploy, and here is a small chart. After MR, we automatically launch the pipeline, which performs syntax check, deploys, and testing. So tests on testing. If everything is fine, everything is green, the manual launch of deploy staging is unlocked and deploy production. For people who understand what they do and understand whether it's going to be deployed staging or deploying production, so that they can understand what's going on. So to wrap up, what have we managed to do? We wanted to create a tool to deploy everything, to get hold of operable clusters with all necessary features, and we were successful in that. We created this deploy, and it helps us a lot. Even under unfavorable conditions, for instance, lack of resources, 15 minutes after we press deploy button, you get an operable cluster. You can enter endpoints and use them in your work. It can be embedded in pipelines, so commands could do that in pipelines. Our team supports several clusters based on this solution, so we're happy with that. We work through deploy. We do almost nothing manually. I will speak about that later. Database management system, team support, we don't do that. They don't do that. We do everything ourselves. We do all the adjustments, so the guys can develop product features and don't have any other headaches. So we're happy with how Postgres replication and balancing is working. Failover is also operable. It doesn't happen very often, but in the past 3 years, we've had maybe 10 cases of failover. Failover is always to the point. It's not for nothing. So we do manual switch over. We do switch over for some interesting things. For example, when we need to move one cluster from one data center to another, we bootstrapped it through deploy in another data center, made switch over, switched the balances, and the master in the new data center started operating without any downtime. So Rip Manager took only a couple of minutes. We did have some failures, though. We wanted to make the solution simple and easy for the teams to use it. It didn't work. It is necessary to understand all the intricacies of the solution, how replication works, how Rip Manager works. This is why the number of forks in our repository is 0. The teams do not do this, are not responsible for it. Maybe it's good. All the issues come to us anyway. So you need to develop something for each cluster. So you cannot really use one and the same deploy all the time. And we couldn't get rid of manual operations, upgrades, relaunches, changes required. Well, all this is done manually. You can do it automatically, but you need to understand what is going on. So the operator is needed, and the operator needs to understand what he or she is doing. So manual operations are still in place. Renewals, updates. So updates is a separate headache. Separate packages must be upgraded manually. You can do it automatically, but then you'll have downtime. So if you do it manually, you avoid downtime. and we do not like to collect packages because we waste time on that. It requires infrastructure for collection to be pushed into repository. What comes in the future? So I'm almost done. In our company, we develop Kubernetes. We have a feeling that it's time to try something new. For instance, to launch a fail-safe Postgres in Kubernetes. We will check it in Stolon and Patroni. Well, we've had interesting reports on Patroni. Maybe it will be the first thing we'll do in the future. Also, we would like to do the same thing but without a cluster to ensure modularity, to be able to turn off and turn on certain things and features without rewriting the deploy a lot, because there are some processing databases which do not need clusters, but they need logging. And we will upgrade the Postgres for PostgreSQL 10.11. So I anticipate it's going to be fun, but we are ready for this challenge. So we will rely on our solution and keep upgrading. So I'm done. Thank you. Thank you. Any questions? So thank you for your insightful talk. So to develop the playbooks, how much time did you spend on that, to develop the playbooks? Well, by trial and error, by some maybe 2 or 3 months. So, and the team was just 2 or 2.5 people. Another question. When you deployed Ansible with Postgres and your solution, have you seen any special features or some unusual situations? Did you have to rework modules? No, we didn't have to write modules for Ansible. We used all embedded capabilities of Ansible. We didn't do anything extra. Thank you. So thank you again for your nice presentation. It's a shame you had this pgpool thing. A question about Barman. Why did you stop at Barman? And about the upgrade, I have a question. I had it from the very start when you spoke about 9.6. You said you were thinking about 10, upgrading to 10 and 11. Well, as to Barman, BG request or backup? So here is my question. While we picked Barman, it is easily configurable. We had a dedicated role for that in Ansible. So we want to look at something else. In ValG, for instance, and LG, well, we have a requirement that all backups are stored internally. So we can dedicate an S3 for that, but why? Why would we do this? The question about the upgrade. We did upgrade manually from 9.4 to 9.6. We deployed the cluster 9.6. We migrated the data to it, and that was about it. And then we throw away 9.4, and everything was fine. Here, another question. You mentioned that you had several clusters, but many more applications. How do you add new clusters? What principles do you use except for staging? So we consolidated all the databases in 3 clusters, in 3 big clusters. Well, we have testing, staging, and when the application operates on staging, we may see that something is wrong. For instance, in the processing database, if we don't like something, we won't use it. otherwise we'll have too much backup and too much load. This is why we check the load profile to understand what's going on in the application, and then deploy the cluster, and all the applications are in production. And the last question. So thank you again for your presentation. I have twofold. How to use vanilla Postgres assembly. I do use that too, but I'm looking at some free of charge capabilities. So what to pick for the backup copying? Well, it looks like Barman, but it has embedded backup check. Why didn't you pay attention to it? Why didn't you use it? Well, I don't know how to answer it in the right way. We didn't look at Postgres features of that kind. Somehow we decided to do that on our own. So kind of decided to reinvent the wheel. Yeah, there is always this dilemma whether to reinvent the wheel or just use the available things. But this Pavel mentioned it was the first attempt, and this attempt looks quite successful.